Hi, I hope everyone's doing well. In this video, I'm going to dismantle the Porsche's MA1 engine and carefully examine it to see if I can figure out why it may have fouled. To be honest, I didn't actually expect to find the reason why, but to my surprise, I actually did. If you like these videos, please don't forget to like and subscribe, as it makes it easier for other Porsche owners to find these videos as YouTube automatically catalogues them. If you are not interested in the disassembly, the diagnosis and examination starts around 28 minutes in. Enjoy. Right, the plan here is to remove, I guess, the ancillaries. Certainly I'm going to get this thing off, which is the thermostat, housing and piping. Get that out of the way. I think also some more of this cooling stuff as well. Get that out of the way. Get the oil pan off, and then I suppose then it's into the oil pump and whatever else is down there. I think that's coming off in two sections actually. That's the oil pan, and then there's a cradle attached to it. Right, let's crack on with it. So with this engine with its heads removed, I'm now have it the reverse way round on the engine stand, and I'm just removing the the thermostat housing and the pipes attached to that, which were actually quite hard, but they are just really a push fit with double O-ring pipes, so they eventually came out. And next up, it's more of those heating pipes. There's two that balance bank 1 and 2. And next I'm taking the crank pulley off, and that little black thing that I put on top of the oil pan, that's actually a tool that helps you turn that crank, because without that tool there isn't any bolts sticking through to actually get a grip on anything to actually turn the engine round. So that's a handy little accessory. That was part of that cheap Temu valve timing kit, if I remember rightly. And next I am removing the water pump housing. So off that comes. And now I'm fishing for the timing chain tensioners. And there's 4 of them, plus an extra one for the oil chain. And next I can turn my attention to the oil pan. So the first part of the oil pan comes off with the removal of at least 20 Torx bolts, so they're all being removed. And yeah, from memory, I'm just getting ahead of myself here, because it's not quite ready to come off. There's 2 more hidden ones that you'll notice I've missed, but I soon spot them. There they are. Now it's free to come off. Right, so here are these oil baffles to stop the engine oil sloshing around from one side to the other too quickly, and prevent oil starvation. There's a rubber seal there, and back in. And so now I'm turning my attention to all the many things hidden under that oil pan, and they're all to do with feeding the oil pump mostly, but most of that's got to come out first before the bottom pan can come off. Once the bottom pan is off, it's then possible to remove the oil pump itself. So that's the oil return tubes. The oil pump is recycling the excess back into the sump. And then once that's removed, there's another cover baffle behind that. There's also a high pressure oil pipe that feeds some castings, block castings at the back that I've already removed. But now I'm just actually trying to work out exactly where the lower sump fixings and fasteners are to get that loose. I think I've spotted most of them. In the real world, when the engine's running, an awful lot of that oil just literally splashes and trickles down past the crank and comes straight back into the sump in that order. So now I think I'm just undoing what fasteners I can see holding the sump, rather the oil pump down itself. So that oil pump is chain driven direct from the crank. So there's a sprocket also to take off of the oil pump, and you can't get to that until you actually get the bottom tray out of the way. So I'm just moving that out of the way. And it's quite interesting actually. Once I finally did get the oil pump off, I really thought I had discovered a fault, possibly a manufacturing fault, that had been there from day one. There is a sort of rubber gasket moulding at the bottom, at the base of the oil pump, and it was missing. And I was thinking that there should be a seal there. And so I was thinking perhaps I've actually discovered something that may have actually caused all this damage in the first place. But when I had actually done some research, it turns out that there used to be a gasket there when they first come up with the 997.2, but later versions didn't have it. I think there's no seals there. That's just sat on, if the camera can pick that up, that's just sat on bare metal. Yeah, it looks like it's recessed for a gasket. After some research, though, it turns out that Porsche had actually dropped that oil seal. If anyone knows why, let us know in the comments. There were 5 versions of that oil pump. There you go. There is the business end of a flat 6 engine. So this particular design on these MA1 engines, or MA103 to be exact, is it doesn't have a separate lower carrier, and so I'm not actually sure what that difference that means, but to actually separate the crankcases, I think it's going to be possible to undo these big end bearing journals and slide the pistons out in this way. This socket set, so these come off quite easily. So I'll proceed with the other 2 con rods. Having gone through the Porsche service manual on this, of course the Porsche way to do it is to actually use a special tool to remove all 3 pistons from, I think it's bank 2. So that somehow fishes out the gudgeon pins and the circlips and then the gudgeon pins. But that's the Porsche way to do it. But I don't have that tool. There it comes. It's quite interesting, the clip coming up now, because once I got the piston and con rod out, the way the con rod parted off the crank, I'd never seen anything quite like it before. So this was my first time ever seeing a split con rod, but apparently it's quite common. Really? Now, if I've got this right, I should push it. There we go. Look at that. Right, let's have a close look. So this is cylinder number 1. Let's have a look at the wear on this piston. Okay. Got some witness marks there, but that's not a groove of any description. Same here. Looks alright to me. Some rings are intact. Yeah, so this unexpected spot where this big end separates. Look at that. Let's just have a quick look at the bearing shell there. It's got all its crank witness marks on it, but I'm not feeling any wear or grooves on that. Not that I'll be reusing those shells. I have a nearly new set of shells in the other crankcase. But look at that. Look at that. How Porsche have done that. That's supposed to be like that. Yeah. As it turns out, these split con rods have been around for years, and it's just a better method of producing them, rather than having to double machine them. But I'm sure a few seasoned mechanics out there will be laughing at my amazement of first coming across it. It really did look as though something was broken when I first clapped eyes on that. So now I am doing my very best to try to remove the big ends of the com rods from, well, whatever else I can actually get access to from this angle. At an absolute minimum, I need one whole bank to have been completely removed to separate the crankcases. So that's what I'm up against without the official Porsche tool to be able to do that. I have actually sourced a tool that allows me to put the gudgeon pins and circlips in correctly one at a time, but doesn't actually allow me to remove the circlips and do the whole process in reverse, basically. But that's what Porsche call for in the service manual. So eventually I came to a stage where it was impossible to get access to anything else to be able to remove anything from that position. I think with hindsight, had I have known, I would have actually ordered some more tools, some smaller socket sets and T-bars and so on, to see if I could have actually got access to the remaining one. Yeah, we've got some witness marks, but no grooves. Nice and smooth. Just your signs of operational wear, but thing to worry about. That's all right. Bearing shells look lovely. From memory, eventually I was able to get pistons 3 and 4. No, beg your pardon, 4 and 5 out of bank 2, but I wasn't able to get piston 6 out of bank 2. And I managed to get a couple more pistons out of bank 1. So that left me stuck. And I wasn't able to get some access, but I should have really ordered a few more tools and carried on trying, I think. It would have been a lot easier. Fairly clean, aren't they? So now I've decided to remove all of the fasteners, keeping the 2 crankcases together, and then see if I can separate it with the piston still in situ, and hopefully that will allow me to get some access, which you finally can, but I don't recommend this. Yeah, it would have been far easier, but there we are. Hindsight is a wonderful thing, isn't it? And until you actually have a go, yeah, you know, sometimes you just have to learn by experience. So I'm just using a T-bar there to loosen the studs holding the crankcase together in a suitable diagonal order. And then that's pretty much everything out of the way. Now I've transferred the engine off the engine stand up onto this table here, and I'm getting ready to split the crankcases now that I've taken the fastenings out and the head studs all out. So I've had a good look at this crankcase and trying to work out the best way to actually split this. So I've had it this way, considered having it the other way, but this seems the best way to go because I've found a spot here where I can get some leverage without damaging anything, and then there's 2 spots here, one here and one here for leverage. So I've gone through my tool collection, and let's just get the camera in a good spot. And yeah, it the ideal wedges are these. Don't know, sure Porsche wouldn't approve of this tool, but it's just going to go in there perfectly. And then screwdriver goes in here nicely, this particular one. So I think it's a case of finding what's best to get some leverage on this and get something that's going to wedge in there without without actually damaging anything. So here we go. So as you can see, once the crankcases are split apart like that, you can get some limited access on the crank itself to undo some of the big end bearing fixings. But again, access is still extremely limited. And the problem I was coming up against here is, in so doing this, you could get access to one particular bolt, but then of course you needed to rotate the crankshaft somewhat to get to the next one. And with it split like that, it's impossible to actually rotate it unless you push the 2 halves back together, making it very time consuming and awkward. Right, I filmed what I could of that. Now that took a whole day. I was coming back and forward to that because it was so tedious. Anyway, I've got the critical cylinder 6 out. I'm just about to take cylinder piston 6 out. just about to take free, but this is quite a sorry state. Look at that, and just look at the rings as well. They're almost kind of mashed in there as well, aren't they, with the metal? So I have to conclude this cylinder has I would imagine this has somehow suffered a serious squeeze in that cylinder. And let's have a look at the crank journals. These journals all look pretty good to me. No gouges in any of them. Everyone feeling smooth. No ridges. That's all. One crank, which is spotless. Journals look brand new. All of them spotless. That will be the envy of some Porsche owners, or rather some mechanics working on some Porsche owners' cars, I should think. And there's just one final piston to remove from this crankcase, and that's everything out. And the piston is a good one, even though the cylinder has a couple of nasty scratches. I think this one can be reused as well. That is good news. I think I got a little ahead of myself there on cylinder 3, because I was looking at the damage on the bore of cylinder 3, and in particular there's right at the top of the bore and then all the way down, and right at the top there's quite a nick in there, and then that corresponds to, which I completely missed when I showed the camera because this is smooth, here, these two great nicks here. And so there's a chunk there and a chunk there. So now that the crankcases are finally separated, it's time to examine the bores and the pistons a bit closer. So I've cleaned up some of the pistons, at least some of the good ones I think I can use, and was getting a little bit excited. I thought there would be 5, but there's actually 3, and even then the 3 aren't perfect, but they certainly look usable. There's a little, they've all got scratches on them, but that's not really deep enough to get your fingernail in, so that's cleaned up quite nicely. Same with this one, a bit more of a scratch this side, but again it's not that deep. That was out of cylinder 2. That first one was out of cylinder 1, and this one out of cylinder 5. little bit of witness mark there, but no wear. And again, they've all got scratches, as I say, but these ones aren't as deep. So they're the three best ones, so I think I can reuse them. And then if we take a look at the other ones, which I think I'm going to have to replace regardless, there was such a deep gouge into that one, which was cylinder 4. Cylinder 3, unfortunately, great scrapes on that, but something has squashed between the top of this piston and the cylinder head, so that's pushed a chunk into the edge of the piston, so that's the end of that one. God knows what that was. And of course this is cylinder 6, and yeah, the skirt is incredibly worn on both sides, and you can see where the piston ring would have been. Yeah, say no more. In case you're wondering, those pistons, they're so clean because I use this Chem Dip carburetor cleaner to clean them, and I shall be dipping the valves in that to clean them as well once I've removed them. So I bought this valve compression tool from Temu. It comes in this red case here, full of other things. I've no idea what they're for, but it's got this very handy bar and it's 2 support brackets which are universal, and you can screw them wherever you like, and then you can adjust the pin, and it's got this perfectly sized attachment that pushes down quite nicely on the valve springs here. See that? Like so. That's what I'm using to remove that. So I'll get all of the valves out of bank 1 and bank 2. We'll take a look at that cylinder 6 exhaust valve with the hole in as well, and fingers crossed the valve seat will be in good condition. If it's not, I'll have to get that repaired. Here I'm removing the rest of the valve spring collets, and as each valve comes out, I'm being very meticulous to mark each individual one so that I can put them back into the correct position if I choose to keep them. Right, I've got cylinder 6 exhaust valve out, and it does look good news for the valve seat. So let's just take a look at the valve itself a little closer. And you can see where it's been just burning through, almost like it's been melting the material as it's been exhausted out. But if you look at the actual edge of that valve, you can see marks on them. So what I would imagine has been happening here is, as chunks have been scraped off the cylinder wall and the piston skirt and been ejected through the exhaust valve, I should think some of these chunks have got stuck between the closing valve and the valve seat, and that's probably started a fracture off in this valve that's led to this eventual blow through and then opening hole to the point where it began to misfire. But this is the valve seat. So that's cylinder 4, 5 and 6. So if we take a quick look, and it was, I'm calling them valve seat A and valve seat B, but it was, so that seat looks pretty good. Well, you can see they're all good, but that one in question looks pretty good. So there's no reason why a new valve and some valve grinding paste shouldn't clean them all up nicely. So that's good news. So that valve can sit up there along with cylinder 6's spark plug. Let me just remind you the state of that spark plug as well. Of course, when this was misfiring as well. Not surprising, is it? The hole and the state of that spark plug. I've given them all a clean and thorough inspection. Now this one on cylinder 6, I've marked them A and B. So with the one, as you look at it face on to the left, would be A. So B, so if you remember that A had the hole in it. Looking at B here, you can see there are dents and dings in the valve seat surface. So this is obviously explains what actually happened to its adjacent exhaust valve to have that hole in it. These would have been the beginnings of the damage on the edge, causing the fracture. And so these would have been particles coming off of the cylinder and the piston in cylinder 6. So moving towards a conclusion for this video, I'll show you where I am with everything and also go through a shocking discovery that I've found. At least I've got to the bottom of the issue here anyway. So let's just give you an update because the next video after this one I'll be making will, fingers crossed, be rebuilding this engine. So I have borrowed someone's sandblaster and sandblasted the sump there, so I'm going to be spraying that silver. These parts here, I'm taking these off to be media vapor blasted, I believe it's called, which will return those cam covers and all of the induction components there to their original aluminium factory finish. The heads here I have steam bathed, so they're all nice and clean. All the inlets are great. Got one more head there to do. All of the other parts are there waiting to go. I've got my lovely crankcases here, those lovely new ones. And I've got the old crankcases here, which I've given a good jet wash and clean. Yeah, let me just go through this with you. So, yeah, I had all these bits at a friend's machine shop yesterday as we were cleaning a lot of stuff. Prior to that, I measured someone had actually contacted me and suggested I look at the cylinders. They'd suggested that they can shrink at the bottom. So yeah, I gave them a measure last week, and certainly cylinder 6 appeared to be a bit suspect. And yeah, that was confirmed yesterday by a third party as well, using the old analog bore gauge. I've got a digital one here. But the giveaway was, yeah, if we use this old piston, which would have been out of cylinder 4, I think, so this one here, you can see that's a fairly good fit still, and it sinks right to the bottom of the cylinder, no problem at all. I'll just pop that out. We try and do the same with cylinder 6. That just doesn't happen. It starts to become wedged. So of course the old cylinder and if we just look at the play at the top there, it's still quite tight there. You can see the skirts on these, on this cylinder, piston, has had to wear considerably. You look at the play there, and that's had to wear to that extent so that it doesn't seize completely. So that'll reach the bottom. So that's suggesting there's been some shrinkage there. Now, when I measure this with the bore gauge, it's a sort of oval shape, really. It's pulled in along this plane here. So if you imagine an oval, that's the kind of shape we've got there. So I'll just go through that with a bore gauge, which is this instrument here. Switch it on when it's compressed, a varying reading. So it's shrunk along this plane here. So let's just get the camera so you can actually see some reading. You may have to look at this upside down. Okay. But no matter, because we're not really interested in exact numbers here. What I need to do is get this to a 0 point. So when I tilt it one way, it will go negative, and when I go the other way, it will go negative. That's not, that's a positive there. So if I zero it there, now if I move one way in the plane, it's negative. The other way in the plane is negative. So keeping it on 0, that's perfectly, don't know what the word is, symmetrical possibly to the bore. That's just exactly zeroed. Now if I slide this right down to the bottom, just going past just going past where the scoring is, to the bottom of the skirt again, to the smooth area again. So that's negative there, and it's coming up, but now it's going positive. It's going positive 0.1, these are millimeters, 0.11. Now it's going towards negative again, so there's our negative. Yeah, the camera's picking the gauge up there. Yeah, so if I'm coming back here, it's maxing out at 0.1 millimeter, and then it goes towards negative again. That's now slid right off the edge. So 0.11 there, and then it starts to fall down again, back at the peak. So the peak there is 0.11 millimeter. I come back up towards the top of the bore again. You can see the gauge has retained this calibration at 0 where I started from. It starts to go negative there. Okay, 0.1. So if I can zero that again and give it some calibration. Actually, no need to really, is there? Okay, zero it there. So that calibrates it at 0 again. So it's negative there. It's negative there. Pop that down to the bottom of the bore again. and its peak is 0.09 millimeters now. And if I can show you where that I'm measuring there, right down near the bottom of the skirt there. I can go right onto the scored bits here. You can get a reading there. It's coming towards positive. 0.2035, 0.05 millimeters there. So there you have it. This bore, cylinder 6 bore, has shrunk at the bottom of the cylinder. So what it must have done, come around this side, where you have the crank carrier here, this must have tightened up and pulled the bottom of the cylinder in. So I mean, how can that happen? How does that happen? I mean, is that bad casting material? Is it a design fault? So there you have it. I must say I'm really not feeling good about this situation. I'm thinking if I go ahead and rebuild, if I buy myself 3 more pistons and piston rings and everything require rebuild with that new crank, I'm thinking it's, you know, it's just going to happen again. The cylinder could shrink, and here it is again. I'm thinking, you know, really these need to be bored and relined with something that's not going to shrink. So I'm not feeling good about this at all. Anyway, hopefully the next video I will be rebuilding things, and I will have had plenty of time to sleep on all of this and give it lots of thought. So hopefully things will be a bit more positive in the next video. Anyway, thanks for watching. Don't forget to subscribe, and catch you in the next one. Bye for now.